This is Roland Leong, Managing Editor of Shotgun Report. We are going to chronograph, pattern, and analyze a shot shell. It will be the Federal 12-gauge 1-ounce, 1180 feet per second number 8s, shot through a Beretta DT11 using a Muller U3 choke. We'll be using an Oler 35P chronograph. The muzzle will be 8 feet from the first screen. We'll be using Shotgun Analyzer version 4.1.5 by Target Telemetrics, running on Windows 11. If you find this information useful, please subscribe and please like. We fired 5 shots through the chronograph, 5 shells through the chronograph. You can see the data on the tape. The fastest velocity was 1194 feet per second. The slowest velocity was 1159 feet per second. The extreme spread was 35 feet per second. The mean of the 5 shots was 1179 feet per second, and the standard deviation was 14 feet per second. The first pattern .330 pellets hit the sheet. The center of the pattern was slightly to the left and above the green aim point. 50 of the 50 pellets hit the 10-inch, were within the 10-inch green circle, giving a 0.64 pellets per inch density in that 10-inch circle. In the 20-inch circle, 142 pellets were counted with a pellet density of 0.45 pellets per square inch in that 20-inch circle. In the 30-inch green circle, 243 pellets were counted in the 30-inch circle, and the pellet density in that 30-inch green circle was 0.34 pellets per square inch. In the 25-inch red circle, 189 pellets were counted with a pellet density of 0.39 pellets per square inch. Assuming a standard clay target at normal tilt, in the red 25-inch circle, the software calculated that there would be a 97.3% chance of a kill of the standard clay target at a normal tilt being killed. The software calculated that with a standard clay target flying through the 25-inch circle, that it would be a 97.3% chance of it getting killed. The shot ratio, 64% of the pellets were above the horizontal line and 36% of the pellets were below. 73.64% of the total pellets that hit the sheet were within the 30-inch circle. This is the second pattern. And as you can see, this pattern was considerably to the left. "332 pellets hit the sheet. 68 pellets were in the green 10-inch circle. In the 10-inch circle, there was a pellet density of 0.87 pellets per square inch. In the 20-inch green circle, 171 pellets were counted. In that 20-inch green circle, there was a pellet density of 0.54 pellets per square inch. In the 30-inch green circle, 273 pellets were counted. In the 30-inch circle, there was a pellet density of 0.39 pellets per square inch. In the 25-inch circle, red circle, 228 pellets were counted with a pellet density of 0.46 pellets per square inch. In the red 25-inch circle, it was calculated that a clay standard target at normal tilt would have a 97.96% chance of getting killed or broken. The shot ratio was 58-42, with 58% of the pellets being above the horizontal line and 42% below. The 30-inch pattern was 82%, which essentially gives this particular choke almost greater than a turkey type full choke. The third pattern was more centered. 315 pellets were counted on the paper. 53 of the pellets were in the 10-inch green circle. Pellet density 0.67. 150 were in the 20-inch green circle. Pellet density of 0.48. 243 pellets were in the 30-inch green circle. Pellet density of 0.34. 208 pellets were in the red 25-inch circle. Pellet density of 0.42. A 96.18% kill percentage in the red circle on a clay standard normal tilt target. Shot ratio of 58% above the line and 42% below the line. 77.14% of the pattern was in a 30-inch circle, giving greater than turkey full type choke for this particular pattern. The fourth pattern was slightly to the left. 334 pellets struck the paper. 47 pellets were in the 10-inch circle, pattern density 0.60. 156 pellets were in the 20-inch circle, pattern density 0.50. 264 pellets were in the 30-inch circle, pattern density 0.37. 25 in the 25-inch circle, 219 pellets with a pattern density of 0.45. Kill percentage 98.33 on a clay standard normal tilt target. Shot ratio 50-50 on this one. Again, a very high 79% of the pellets percentage in the 30-inch circle. Very, very tight choke equivalency. And finally, the final pattern. "331 pellets hit the paper, 10 pellets, 10-inch in the 10-inch circle, 443 pellets with a pattern density of 0.55. The 20-inch circle, 158 pellets, pattern density of 0.50. In the 30-inch circle, 273 pellets were counted with a pattern density of 0.39. In the 25-inch circle, 212 pellets, pattern density of 0.43, 99% kill possibility of a clay standard normal tilt target within the red 25-inch circle. Shot ratio is higher on this one. 73% of the pellets were above the line, 27 below. Again, a very tight choke on this. 82% of the pellets were found within the 30-inch circle. Now, what does all this mean? Were the 1-ounce AVCI shells better than these federal 1-ounce shells? Well, let's take a look and see. We took the pattern densities of these AVCI shells and the federal shells and put them down at 25 inches and at 30 inches. And the mean average for these two numbers, for the AVCIs and the federals, are here, 0.476 for the AVCIs and 0.43 for the federals. So one could look at the average and say, yeah, the AVCIs are better. The pattern density is higher for the AVCIs than they are for federals, so the AVCIs are better. Looking at the 30-inch pellet density, the AVCIs are 0.41 and the federals were 0.366. So again, the AVCIs had a higher density, so the AVCIs are better. Well, you could say that, but you would not be necessarily correct. The correct way to evaluate whether the two means, the two averages of the data sets for the AVCIs and the federals, whether they are indeed different, would be to do the t-test between those data sets. So I've entered the data sets for the pellet density in the 25-inch and the 30-inch circles for the two data sets of the AVCI and the federals, and calculated the t-statistic to disprove or reject the null hypothesis that the AVCI and the federals have no difference. And because the t-statistic number exceeds the critical two-tail number, we can reject the null hypothesis that the mean between the mean of the AVCIs and the federals are similar, so that the conclusion is that the there is a difference between the AVCIs and the federals in both the 25-inch pellet densities and the 30-inch pellet densities. Unfortunately, the fly in the ointment is, if you go back to the original patterning of the AVCI 1-ounce 8s, you'll see that I made an adjustment, a note that for some reason the AVCI shells showed an abnormal number of pellet hits on all the patterns that we collected. So for whatever reason, the AVCI shells counted an abnormal amount of pellet hits on the patterns that we have no explanation for. So the data sets that we collected on the AVCI 1-ounce 8s are somehow flawed. Well, the mathematics is good, but the data collection is somehow flawed.